Hello everyone. This is the audio supplementary material, the audio comments of the slides of the second part of the course, People Detection of Biometric Recognition. This is the introduction to the biometrics part of the course. So let's outline the material on biometrics, this second half of the People Detection of Biometrics course. So we are going to introduce what is biometric recognition, some of the more important biometric traits, what is biometric authentication, different modalities, and then also we will introduce multi-biometrics. Multi-biometrics, the topic of combining multiple evidence for biometric purposes, will be a specific set of slides at the end of the course. So this is the specific contents of the biometric course. So first part of the course is this introduction, and also there will be a second set of slides, also introductory, discussing or defining the typical performance measures that are used to characterize the performance of biometric systems. And then we will jump into the three most important biometrics. Well, in fact, the two most important ones, fingerprint and face. Another one, iris, which also finds good application nowadays. And the last one, signature, is not that important, but represents well a kind of biometrics of growing importance. These are behavioral biometrics, and this is signature. Signature is a biometric modality that it's useful for identification. The marketplace for signature is small, but technology behind signature and the problems behind signature, technologies and factors affecting signature are similar to other biometrics like speech, like keystroking, like gait, any behavioral trait that can be acquired from the human that is affected by the way we behave. And signature is one of these kinds. The other three, fingerprint, iris, face, are physiological biometrics, are only characterized by the image structure of a specific part of the body, which is not changing usually with our actions, our behaviors. And then at the end, we will discuss also about fusion, combining different evidence, and also other auxiliary advanced topics. So what is biometric recognition? Basically, biometric recognition, or just biometrics, is the science of identifying a person, characterizing the identity of a person based on physiological or behavioral attributes. So physical, like face, fingerprint, iris, some of the parts of our body that can be sensed somehow, and then based on that information, image or signal based information, we identify the person. Or else the person can also perform an action or a series of actions, and based on that behavior we can also identify or recognize that person. So both of them, physiological or behavioral, can be helpful for identification. So there are many different traits like fingerprint, speech, iris, face, signature. All of them are useful to some extent, and depending on the scenario and depending on many factors, operational factors, can be helpful depending on the sensors that we have are at disposal. Imagine we have a smartphone, then the smartphone can have some sensors already embedded in the smartphone that can be helpful for identification. We can have a video camera, that CCTV camera that is acquiring remotely, some scene that can be used also for recognition at a distance based on video, and we can have many more contact-based like fingerprint sensors and so on. Basically, the biometric traits that we can have can be divided into big classes: physiological traits, as I mentioned before, and behavioral traits. Physiological, we have fingerprint, face, facial images, iris, ear, blood vessels, body profile, body parts. Every part of the human body that has some discriminative content, discriminative information, can be sensed, imaged, and then used for identification. There are other also biological traits that can be measured to some extent, like DNA, EEG signals, odor, but these other more biological traits are usually not automated to full extent. So they are sometimes semi-automated. There are some manual process involved, for example, to obtain a DNA, or some delay in processing automatically these biological traits. So usually we don't find like fully automated biometric systems working real time online, like in the left part of the slide. So the left part of the slide usually represents the biometric systems that you will find commercially. And let's say with this kind of biological information, you can also build biometric systems, but the state of the technology is not up there to really automate fully the whole process of obtaining this kind of information and then resulting in an immediate biometric identification. So this is kind of some of the future of biometric systems. And then the last part is behavioral traits, the ones that are related to some action that we perform, and then based on that action or behavior, then we can extract some pattern that is distinctive and it's useful to identify the person, like speech, signature, handwriting, gait, keystroke dynamics, and so on. So you can find here some statistics of the market share. So it's the relative importance of the different biometrics and how this relative importance has evolved across time. So from 2000s to 5 years ago, so after 10 years of technological advance in biometrics. So you can hear that in the beginning, fingerprint was the most important in the 2000s, followed by face, hand, iris, voice. So you can see that voice signature, representative of the behavioral biometrics, were small compared to the physiological biometrics. And now, going to 2015, and even nowadays, the market share for behavioral biometrics like signature, voice, keystroke patterns, and some others related to behavior is growing in importance. Also, you can see that fingerprint has less importance compared to 2000s. Face is growing, iris is growing, so you can see that the market is more divided between several biometrics, and this is because the amount of applications is growing and the diversity of scenarios is growing. So we have really a variety of biometrics in the market now, and also not only in the market but in research laboratories. The previous slide was about the market share divided by different biometrics. Here you can see the evolution across time of the overall size of the market. And you can see that biometrics is growing very rapidly in terms of overall size. So this is US dollars in millions. So you can see that the market is growing very rapidly. And also this behavior until 2015 is also growing in importance in recent years. So we can see that biometrics is growing and is expecting to grow even more because of the integration of biometrics in several smartphone devices and other personal devices. So many countries have already implemented biometric technologies at national level for like large-scale applications, like national ID programs, elections, silver surveys, payrolls, health surveys, and so on. And this is an example of some of the most important countries where this kind of large-scale biometric projects have been deployed, including Asia, America, and Africa. Also, some countries in Europe. This chart is not completely up to date. So about history of biometrics. This series of slides about history is not that important. So I'm not going to ask about any details here in these slides in the exam. The exam is going to be more focused in general concepts, like the example questions that I have uploaded to Moodle. Please check them. So here is just some information for you, but not really that you have to really study it carefully. So it's just some background history for yourself, not for the purpose of studying it by heart. So biometrics has been with us for many years, for a very long time. So even if ancient times, as old as 30,000 years old, we can have evidence, or we can find evidence of different parts of the body embedded or printed in stone, in paper, in different forms. So you can see in the slide in some hands in caves saying this painting is mine, or even some carvings in all the stones. This stone or this piece of art is made by me, and this is my fingerprint. So the sense that some parts of our body or images of parts of our body are representative of ourselves has been there for almost the full history of the mankind. So, but scientifically, the usage of that information for really identification purposes started in the 19th century. So the first systematic system using biometric information, in this case hand images, was in 1800, and then from 1850 till the end of the 19th century. So you can see some scientific developments very important, like the Bertillon system that was capturing some anthropometrics. This is some distances of the body, like distance between arms, height, some contour metrics. And these metrics, anthropometrics, were used to identify individuals in a police system. And then Galton, that developed a really systematic study on fingerprints, a classification system. And then we jumped into the 20th century, and then some automated procedures were developed to automate fingerprint processing and matching, signature, speech, and all the others. And in the 90s, more or less, there was a big advance in large-scale identification systems in almost all parts of the world. So this is an image of the Bertillon system. So you can see a person here. This is Bertillon capturing different sizes of the body. So you can see the arms, you can see the head seated, and different parts of even the arms, like from the fingernail to the elbow, and so on. So different distances of the part. So that was like systematically measured, and that was stored, indexed in a file in the police department, and those measures were used to identify people. So several techniques can be used for identification. Not only these biometrics, which are measures of the body. So this is only one way to identify people. In fact, some kind of recent or the more technologically advanced way to identify a person. The most typical way is either based on something that you know. This is knowledge-based identification. For example, you have a password, a PIN, or token-based identification. You have a key or a smart card or something that you own that identifies you. Biometrics is the kind of the third type of identification based on something that you are, or something that you produce, or something that in the way you behave. So these are kind of the three ways you can be authenticated. Something that you know, you have, or you are. Biometrics is what you are, and is sometimes seen like the strongest way for authentication, but it has also some limitations. So usually the strongest way to identify a person, or the more secure, will involve a combination of like in a kind of two-factor or three-factor authentication, combine PIN and biometrics or token and biometrics. I have my phone, and I have a fingerprint sensor, so I have something, and I am the person that is interacting with my phone through the sensor. So you have a combination. And additionally, we can have also a PIN for some service or application in the smartphone. So passwords have been used very broadly, but can be lost, stolen, forgotten. So passwords have many limitations. Sometimes it also it's difficult to remember passwords. So many limitations of passwords can be overcome with biometrics. So biometrics, in fact, can be a substitute in some applications for passwords. There are estimates of big fraud damages involving card fraud, credit card fraud, fraudulent phone use, ATM withdrawals, like many different kinds of fraud that are related to stolen passwords or yeah, some kind of problem with passwords. So yeah, you can read this by yourself. It's not that important. It's just an example of how passwords can be fooled and can be circumvented sometimes, and then generate big frauds. And we can generate like strong passwords, but then this is going to be difficult to remember, to keep, to manage. So passwords can be a solution sometimes because if we want to have a simple system and the security needs are not very strong, then passwords can be the best option for authentication. But in sophisticated, elaborated, or comprehensive systems, let's say in our smartphones, if we want to really protect valuable information like our personal data, bank accounts, and so on, then passwords may not be the best option. And this is why mainly biometrics is growing in importance now. Another example of how vulnerable are passwords, 35 of the most popular passwords were all like very, very, very easy to guess. And this, in fact, these 12, the first 12, I think they accounted for something like 1% of the world population, something like that. So people tend to use very, very simple passwords that are very, very easy to guess. Not all the population, but an important size of the population. So benefits of biometrics. Your biometric cannot be lost or forgotten, and you must really cooperate to provide your biometrics. So it's kind of more controlled and difficult and more difficult to fake and to circumvent and to attack. But there are challenges also in biometrics, and this is because biometrics is a very wide field, and the sophistication of algorithms and techniques and sensors is growing and growing, and it's a complex technology. So we have to deal with acquisition quality, device interoperability, multiple devices. I want to that my device works with your device with different resolution, acquisition, configuration, and so on. There are variability factors. I have an image, and then I have varying pose. I have different illumination. I want my camera to work in all conditions or as many conditions as possible, even if my face in front of your camera is rotated or I have some kind of I don't know, change in illumination. I want to be able to recognize or to authenticate even if those variability factors change. We can have attackers also that try to mimic our biometric. We have aging also. My face is not the same face today and in 1 year, and also in low-term variations related to my facial hair, my beard, my I can have or women can have makeup or she can have makeup one day and the other day without makeup, and this is kind of variation across different sessions that will affect a biometric based on face recognition, for example. That same happens or can happen also to fingerprint and other biometrics. There is some variability across sessions that we have to deal with, and many other factors that make biometrics really a challenging technology, very important one. So in order to have a good overview of all the factors that can affect biometrics and that should be addressed and considered when designing a biometric system, let's start with the basics. What are the elements of a good biometric system? The first elements of a good biometric system are, you can see here, universality, uniqueness, permanence, and collectability. So universality, so this is one of the elements that we should aim in biometrics, to have the largest universality possible. So universality means that every person should possess this trait. So in practice, not all biometrics are universal. For example, some people, they don't have fingers, or can have the face mutilated, or can have very, very low quality biometric because of some circumstance, and then that biometric may exist, but maybe of such low quality that will be unusable, will be not valid for recognition purposes. That in this way, we don't have a universal biometrics. A percentage of the population won't be able to use that biometric. Uniqueness. So different biometrics have different level of uniqueness. So uniqueness relates to the degree in which that biometric can be used for identification. It's the discriminative power of that biometric. So we know that, for example, iris is more discriminative than speech, for example. The probability that you find two people with similar speech, that probability is higher than finding two people that have similar irises. So therefore, uniqueness for speech is lower than uniqueness for iris. So the larger the discrimination or discriminative power, or the easier is to discriminate people based on that biometric, the easier it is, then the more unique is that trait. So the highest uniqueness are in traits like fingerprint, like iris, where the amount of information, discriminative information, is higher than in low uniqueness traits like signature sometimes, or keystroke, which sometimes are called like soft biometrics. Soft biometrics because you cannot really identify the full world population based on that soft biometric. It can be useful to identify in a group, but not in a large set of people. You will need a more harder biometric. Permanence is also important. We want to have permanence in biometrics. Permanence relates to the degree of invariance over time. So the more permanent is a biometric trait, the best. Iris and fingerprint are more permanent than face, than speech, and than behavioral biometrics. We have also different levels of permanence. Short time sessions across the same day, or even in just a few days. Medium term, several weeks, months, and long term across years. And even from acquisition session to acquisition session, even just in few seconds, if the conditions of the environment change, then the image or the biometric acquired will change also. So we have not only the intrinsic permanence of the biometric trait that is changing over time, your face can change over time. We have also a variation related to changes in the environment. So really the change that we will observe in a biometric image and in a biometric signal will be a combination of the changes in the trait itself, in the body part itself, and changes in the environment. And this permanence includes both collectability, and this is the characteristic to be quantitatively measured. This is the easiness to capture. If we have cheap sensors that are non-intrusive and that can really measure the trait easily, cheaply, and without any effort from the user, then the trait will be easily collectible, and this is very convenient and a very good property for a biometric. So previous four were the kind of the four more important elements that we want to have in a biometric. And then we have also different system level criteria. The three more important are performance, acceptability, and circumvention. Performance relates to the accuracy in the classification. This is the related to the identification error. The lower the identification error, the better. So we want to have high performance in identification. Speed, robustness, resource requirements, all of this is related to these system components and performance that the system that we build is able to offer us. Second one is acceptability. This is how the people are willing to accept or use a particular biometric trait. For example, nowadays, the people may be reluctant to use a touch interface because the people will not want to touch any surface. So perhaps having a sensor that it's a remote sensor that it's acquiring the biometrics at a distance will be easily or much more accepted than having like a touch sensor that you have to touch. Imagine in a gym or in a place in a door that many people have to cross. And at the end we have circumvention, and this is the capacity of the system to be robust against attacks. So if an attacker can easily fool the system, then the biometric system will not be good enough. So we want to have really robust systems against attacks with high performance, highly accepted, and difficult to attack. So this slide summarizes more or less in general terms, and this is not like a hardcore definition. This is just, and depends heavily on the scenario, on the particular implementation, on the particular technology. Just some, it's only like an indication, so you can compare between different biometrics. So fingerprint, usually you have very high accuracy in identification, so the uniqueness is very high, permanence is very high. Easy of use is medium, sometimes you have to interact with sensors. Acceptance is usually low, the user has to touch the device, and then the device for fingerprint may be dirty, so on. You can compare that with face at the end of the slide, comparing fingerprint with face. The accuracy is medium compared to fingerprint. Ease of use is much higher. You don't have to touch anything. It's very fast, very convenient, and the user acceptance therefore is very high. So the rest of the slide really compares the different biometrics in the same way between low, medium, and high. This is an example of a working system, very advanced system called, well, that Morpho was a company that changed the name very recently, last year. Now it's called IDEMIA. IDEMIA Finger on the Fly. IDEMIA Finger on the Fly is a system that it's now being implemented in some airports. And basically without any touch, you just cross your full hand in this across this kind of sensing part, and then automatically the system has several cameras and is able to track and to use your 5 fingerprints to be recognized without touching anything. So it's fingerprint on the fly. So benefits, if properly implemented, biometrics can ensure increased security. You will be protected against unauthorized users, and it can overcome some of the limitation of passwords and pins. Also, it's usually more convenient, so you don't have to keep your password or to keep your smart card or to keep a token, so your biometric will go with you. So it's usually more convenient when you apply properly biometrics compared to traditional methods. And also it increases the accountability because the system will know that it's really you each time you access the system, so you can keep a log of all the interactions with the system and all the authentication steps and authentication trials that you launch into the system. So it enables increased accountability in the system. So it both detects fraud, real fraud, and also it's in some applications is dissuasive. So you can have like a biometric module, and just having that biometric module will prevent many different attackers to just try to enter the system. So you can have also a kind of dissuasive effect even just by considering a biometric module in your system. So this is an example of a large data set of face images. This is the kind of face images that face identification system will store. So you can see in this example that the faces are already aligned, cropped. This is cut to have only the face information, so the background is eliminated. So this is usually where the kind of templates that the portions of the face that are usually stored in the face templates. So in biometrics, now going into the diagram block of the systems, so we are going to from the concepts that we have just presented, we're going to really see the structure of the systems, the different modules of the systems built on biometrics, and then in the next sets of slides we will go one by one to the different biometrics. So we have two different main architectures for biometric systems. One is verification, second one is identification. It's different. Verification, so you can see here that it's a system that tries to respond the following question. Is this given person, so you have as input a given person who he claims to be. So this is, I'm claiming one identity and the system checks if my claim is correct or not, which the response can be match or no match. So this is binary decision, yes or no. I'm claiming one identity and the system checks if my claim is correct or not. So as input, I must input biometric evidence, for example, my face. I say I'm Julian. The system should have stored a pre-enrolled sample of my face. The system hears my petition. My petition is I am Julian with this face. The system will compare the input face to the pre-enrolled face, and then based on that comparison, the output will be match or no match. Basically comparing a distance or a similarity between my input face and the pre-enrolled face. So verification is just one-to-one comparison. Second architecture of a biometric system is an identification system. In an identification system, the question is who is this person? So the input to the identification system is not an identity, it's just an input biometric. For example, just an input face. I have a face and I want to identify who is this face from. And then comparing that input face to a data set of faces, then we will return the identity of the person most similar to the input face, the most probable person in that database. So the answer, the output of the search in this case will be an identity out of the database that we are going to compare. In this kind of identification systems, therefore, we compare one input to n identities or templates in a database. one-to-one comparison, one-to-n comparison. The output in this case can be just the most similar identity in the database or a ranked list of the most similar identities. The top 10, top 100, top n most similar, and then in a second process, sometimes manual, then we can select out of the ranked list who is really the person. This happens, for example, in forensic identification systems. So this is a summary: identification versus verification. An identification, we determine the identity. In verification, it's just yes or no. It's just responding to the claim. So we have in verification an input claim, an input biometric, and we respond to the claim yes or no. In identification, we don't have input claim. It's one-to-n mapping. It's one-to-n comparisons based just on the input biometric. In this case, it's one-to-one mapping. It's the input biometric to the pre-enrolled biometric of the claimed user. So looking at the diagram, typical diagram of biometric verification system. So you can see that we will have always a sensor that will capture a signal, let's say an image, time series, voice file, some kind of biometric data. And this is the operation of the system. Before the operation of the system previously, we will have to, before the operation, at the previous step, we will have to build this database of enrolled models. So for a number of persons that have been enrolled, we will have to input that information to build a model or a template for each of them. Let's say yesterday I came and I registered myself, and also different people were registered in the previous days. So let's say my model, the model of my face, is already in the system. And then today, in the operation of the system, I came in front of the sensor, the camera, I put my face, and I say, this is my face, and I am Julian. So Julian, the pre-enrolled model of Julian, will be here, selected, just the model of Julian, usually. Different options for selecting and comparing models are possible, but in the standard verification system, only the model of Julian will be here, the model, the template. We will see specific models and templates in next sets of slides. And then my input face, from my face, we'll have a pre-processing module. So we will normalize, we will process, we will enhance the image, the face image. We will select, we will delete the background in order to have, for example, a face that is already cropped and aligned. And then from that face, we will extract some features, image features, and then we will have some neural network that is able to represent the face in a feature space that it's highly discriminative. We will compare the features extracted with the features that are already in the model selected in a match, in a comparison. We will output a similarity score, we will normalize the score, and then based on the normalized score, we will take the decision. If the decision is higher than, the score is higher than a threshold, we will accept the claim. Yes, this face and this claim, I'm Julian, this is my face, Julian, I accept, so you are verified as Julian. Most of the content of the course for the different biometrics that we're going to study, fingerprint, face, signature, iris, is going to just describe what are the typical pre-processing steps for fingerprint, face, iris, what features are used usually in the systems, how we compare this or how we conduct this comparison, and then how we integrate these scores, perhaps with different scores from other systems, and then how we decide. So it's going to the details of the different blocks here for specific metrics. The previous model was specific for just one single biometric. We may have different architectures combining biometrics in different ways. We will look at this in more detail in the last set of slides, but just an introduction We can have, for example, different sensors. So you can see this. You can see these two sensors for fingerprint. So we can acquire or use different sensors and then combine in a multi-biometric approach the information from different sensors. So this is combining multiple sensors. We can combine different modalities. We can have fingerprint and signature. We can have face and voice. We can have many others. We can have multiple instances, for example, 2 different fingers that are used simultaneously, 2 or 3 or 4, any number of. We can have repeated instances, so the same biometric, the same body part can be sensed several times and then combine that information. For example, in a face, I capture a video, multiple frames, and then use all the frames in a biometric system. We can have just single evidence, but combining different algorithms for the purpose of recognition. So you can see that different kinds of information can be combined for improving biometric system. I'm not going to explain this here. In the last set of slides, we will go into the details of how to combine at which level to combine the information from different biometric systems. Applications, we have many, from passport control. So nowadays you can see all around biometric applications, especially now in your smartphones. I'm sure all of you in your smartphones will have some kind of biometric component, either fingerprint, face, or a combination of fingerprint, face. You can also sign with the touchscreen. You can capture your speech and so on. So smartphones are really an excellent hub now for biometrics. Also in surveillance, in back transactions, e-commerce, electronic administration, e-government, and so on. Also, another important element of biometrics is that always when we design or when we use a biometric system, we must be aware of the privacy and legal aspects around biometrics. Biometrics are personal data, like your name, your address, your email. So it's personal data. It belongs to you. It's part of you. And as such, you have rights about your personal data. So, and especially in Europe, because of the GDPR, the General Data Protection Regulation, which is very strict and very protective of the people and the rights of the people, then the usage of biometrics must be taken with care. So a company or a developer, engineer working with biometrics must comply with regulations, must assure your privacy, must protect your templates, must give you the right, for example, to delete your data, to revoke your data, and so on. So there are some privacy legal concerns that are kind of beyond the scope of this course. In this course, we are going to focus on the technology, on the different elements, main elements of the processing and matching for different biometrics. We're not going into the elaborated and sophisticated details of the legal implications. So, but these legal implications may be very important. And also the technology behind privacy protection. This is beyond this course. How to really encrypt the channels, how to encrypt the models, how to assure that level of privacy is adequate with legislation. This is out of the main materials of the course. to that, and that concludes the first set of slides. Thank you.